In this video, we're going to be looking at finding the exponential equation from a data table without using the exponential regression function on the calculator. So we're going to do this by hand. Now, we're going to assume that all of these tables are not necessarily exponential. So what we're going to have to do is determine if they're exponential or if they're not exponential. And knowing they're exponential actually gives you another option, whereas if you don't know it's exponential, you have to prove it's exponential first. So we're going to actually prove that these are exponential functions. So the way we can prove that these are exponential functions is we're going to look at what we call a common ratio, which would ultimately end up being your b value. So let's go ahead and look at the b value first. We'll come back to the a value. Let's determine if this is exponential or not. So the common ratio is going to be how each y-coordinate gets from the one previous. So what is the pattern going from as we increase on our x-coordinates, as we increase on the independent side, how are the values increasing on the dependent side? And we need to make sure that we have a consistent increase on this side. So we go -3, -2, -1, 0, 1, 2, 3. We're going by ones each time. So now I can look at all of these and make sure they all have the same common ratio. And what we determine is the common ratio is a factor. It's a multiple. It's what did we multiply the previous y value by to get the next y value. And in order for this to be a typical exponential function, you have to have a common ratio. It has to be the same factor, the same multiple from y value to y value as we go consistently from x value to x value. So let's try. How would I go from 1 to 2? Well, multiply by 2. So in order for this to be an exponential function, that means that each y value going to the next y value must be a factor of 2. We must have multiplied by 2. So let's check these. How do I go from 2 to 4? I multiplied by 2. So far, so good. So now let's go from 4 to 8. That's multiplied by 2. 8 to 16, once again, we multiplied by 2. 16 to 32, once again, multiplied by 2. 32 to 64, once again, multiplied by 2. So with the data that we've been presented, this is an exponential function. The common ratio that you've just found is your b value. So our b value is going to be 2. The common ratio is what you multiplied by, okay? What you multiplied by. So that's our b value. Now that we've established our b value, let's find our a value. We know it's an exponential function. The a value is actually going to be whatever your y value is when x is 0. So our a value is going to be 8. Now, why is it this way? Well, as you know, y equals a times b to the x. Sometimes you'll see the b written as an r, a times r to the x, representing ratio. Whenever the x value is 0, if I write a times b to the 0, let's see, let me plug in 0 for x. Well, b to the 0 power is just going to be 1. So my a value is going to be the same thing as my y value, because whatever I get for a is going to be y. So when I plug in 0 for x, my a value is what's left, because this goes to 1. Anything times 1 is just that value. So if I were to plug in 0 here, it would be a times 1. If I plugged in 0 times 8, 0 and 8, I plugged in the entire set of coordinates, I would have 8 is equal to a times b to the 0. Well, that means 8 is equal to a times 1. So essentially, a is 8, which is the same thing you have here. So your a value is 8. And we'll do a couple more examples of these to make more sense. So now I'm ready to write my equation. So my equation is now because it's of the format y equals a times b to the x, sometimes you'll see it written as a times r to the x. That's common. The r represents ratio either way. I know my a value and my b value, which is also my r value, my ratio. So my equation is going to be y equals my a value, which is 8, times my ratio, my b value, times 2 to the x. And that's how you determine the equation from the table. Now there's another way you can do it. Once you've established that this is an exponential function, just like we plugged in to find the a value, once we know the a value is 8, let's say we do the a value first. Let's pretend we don't know the common ratio. Let's pretend that I've already told you this is exponential. You don't have to do all of the ratios. And I tell you it is exponential. You could, once you know it's exponential, plug in your a value, which is 8, and then you can pick a point on the table, because at this point we're looking for b, and let's choose 1, 16. So I'm going to plug in 16 for y, and I'm going to plug in 1 for x, because I've chosen this point right here. So that would mean 16 equals 8 times b to the first power, which is just b, which would mean b is equal to 2. And that's what we've already established by finding the common ratio. So there's two different methods you can use to solve this. If we already know it's exponential, you can plug in, select one of the points. 1 is the easiest because then you're not getting into exponents. Plug in 1 if you have that available and solve for the b value. Otherwise, you can find the common ratio, and that will also give you the b value, or like I said, you'll see commonly written the r value. So let's look at the second one. So here's our second table here. Again, you're assuming you don't know if these are exponential. So let's see if we can find a common ratio here. Now remember, the common ratio is what you multiply by. That's important. It is a factor. It is a multiple. You've got to multiply. Some people get confused because you can actually have the y values get smaller by dividing, but remember, dividing by a number is always the same as multiplying by that number's reciprocal. So, for example, if I look here, I go from 27 to 9. Most people would see that that's dividing by 3. But we're not looking for the division here. We're not looking for a quotient property. We're looking for a multiple, a factor. So instead of dividing by 3, it's the same thing as multiplying by 1/3. So let's test the rest of them and see if they have the same pattern. So to go from 9 to 3, again, you're taking 1/3 of 9. So far we have a consistent pattern. To go from 3 to 1, that's the same thing as multiplying by 1/3. To go from 1 to 1/3, that's the same thing as multiplying by 1/3. Remember, this is all the same as dividing by 3, but our b value does not come from what we're dividing by. It comes from our factor, what we're multiplying by. To get from 1/3 to 1/9, we are multiplying by 1/3 again. And to get from 1/9 to 1/27, we are multiplying by 1/3. So this is an exponential function. My common ratio is 1/3. So that's my b value. Okay. So now that I've established my b value, I'm going to look for my a value. And remember, your a value is where your x value is 0. So my a value is 3. If you want to see how we come to that again, remember your exponential functions are a equals a times b to the x. We know our b value is 1/3. Okay, so I can plug in my v value and solve, or I can pick this value here, 0, 3, plug in the x and the y, and see what I come out with. So in this particular equation, let's pick 0 and 3. So I have y equals a times b to the x again, so let's plug in. Let's plug in 3 for y. and let's plug in 0 for x. Anything to the 0 power becomes 1, so we end up with 3 equals a times 1, which is just 3 equals a, which is the same thing that we established. So anytime you have an x value of 0, that is your a for your exponential function. Now, and we're just doing simple exponential functions. We've got my a value, I've got my b value. I can now write the equation. The equation is y equals a times b to the x, or as you'll see it sometimes, a times r to the x, and remember r stands for ratio. So my a value is 3, and my b value is 1/3, and that's to the x power. And I'm going to put parentheses around that 1/3 so that you can see clearly that it's the entire fraction that is raised to the exponent x, not just the 1. That's important. If you forget to do that sometimes, you tend to just stick the exponent with the numerator. It is for the entire fraction.